Afternoon, guys. We're just going to be building up some more RePCBs again. They just keep selling, so I'm going to have to jump back on these and start building a few. I need about 4 or 5 more today, so we might as well just live stream it. So I'm not sitting by myself. I can at least talk to you guys while we do it. Try and remember some fume extraction today as well, so my throat doesn't get as sore. Hey, morning in the US. What part of the US are you from? Discord messages I check daily, so if I haven't answered you within a few days, then no, I've missed it. Ah, nice. I've never been to Maryland. I've been quite a few places on business in the US, but I've never been there. I think the first place I went as an adult was Chicago in winter, and just seeing all the steam coming out the vents in the mornings, like 5 in the morning with jet lag. I loved that place. I think it was actually Halloween, because we had there was like massive decorations in the streets, huge sort of 40-foot spiders and cobwebs. It was really nice. I loved the Chicago area. I've got a face cam coming as well, so we should be able to get my ugly mug on a little pop-up bubble after today. Working on at the minute Game Gears. This is one of the main things we sell, is what we call prestige consoles, so where we build them up and fit all the mods to them. This specific board is a PCB I've made. It's like a clone, if you will, of the original Game Gear board. So if you've got boards that are too damaged, then you can use this clone board to restore the Game Gear. So if you've got, like these for example, see all this blue, how it's all completely corroded. There's blue here, so at that level of damage we wouldn't sell these to customers, especially like these buttons. So if we just zoom in on them, you'll see like all this trace rot. It's eaten through, and this is going, obviously, you can restore these, but by the time you start restoring all this isn't good enough for selling a customer, really. So what we do is we take the main chips off the Game Gear, the thing that make it a real Game Gear, the A6 and the CPU, or the Z80 rather, and we transplant them onto my new board here. So that's the goal. This board is dual, so this is a dual ASIC board. I've just made the single ASIC, and it'll support every single of the Game Gear. So it'll support the VA1, VA2, VA4, VA5. That's in prototyping at the minute. So as soon as that's ready, we'll have effectively 2 boards that cover every single Game Gear out there. Now you'll have to drop me another message on Discord then. I haven't really seen any messages that aren't answered, so it's probably just got overlooked. This board, it's basically a remake of the Game Gear, so when these are too damaged, we can just transplant the key chips over to a new board, which is what we're going to be doing now. So we'll put some flux on the old chips to reflow them here. Zoom in a little bit for you there. Focus up a bit. There we go. We just have to hot air this chip off, which is the Z80. And then these two chips, which are the A6, the application specific something or other. Basically a custom chip that makes the Game Gear what it is. So all the other stuff is just generic. This is RAM, this is all caps and transistors, so that doesn't really make a Game Gear anything special. But the chips we're taking off are what make it a Game Gear, so that's what we like to do, is to try and keep the Game Gear the real device. So when you're playing it, you know you're playing the original hardware. Thanks, Sophie. I'm glad you enjoy the videos and the work I'm doing. It's much appreciated. And then with fume extraction, I don't tend to run the fume extraction once a hot air, because the hot air itself just disrupts the fume extractor, so it just makes it even worse. It just blows fumes everywhere. I would ideally like a better solution, to be honest, for proper fume extraction, I guess, when you're hot airing, because doing it regular is obviously not the best for your health, I don't think. Oh, the ribs, they were amazing. I think there's room for improvement still, but they were just chuck ribs, not short ribs. I forgot they'd ran out of the short ribs, but flavour-wise, 100%, absolutely gorgeous. I think I'm going to try top side next, do like a roast. Fishy smell, yeah, to be honest, you don't smell it when you're working on it. You tend to be almost immune to it after a while because you're just used to smelling it. But if you leave the room and come back in, the room stinks of fish. But when you're sitting in it, you just don't really notice. So like now, I don't really... You notice, say, the first little whiff, and then that's it. You don't notice after. But yeah, if anyone comes in the room, that's the first thing they say. It stinks. And I've got a ton of prototype stuff coming today as well from the new factory. So I might show some of that off. Usually the prototypes don't always work first time, but I figured I might as well show some of that off as well if it comes. I missed the delivery. I was setting up for coming on here and missed DHL, so if they come back I can possibly show some off later. If not, I'll probably show it off tomorrow. That's them ones done. Now we want to do the big A6. Hey Woodridge, thanks for joining. Glad you're liking these. I've had, as soon as I originally did TikTok, that was where I kind of did all my videos that really blew up. They were just like 3 to 5 minute vertical videos, just explaining all the key points. Then I moved on to, I did horizontal, slightly longer videos, because people were missing them. As soon as I did that, the TikTok people wanted the vertical videos back. And then people that had them wanted live, and then as soon as I start doing live, people now want the original vertical short videos. So I think there's pretty much a demand for every style of video. But the lives are working quite well, to be honest, because they just fit in with... I don't have to think too much. I just press record and start working. So it's a bit more easy on the workload. If I haven't got time, I'm basically just doing my day job anyway, so it doesn't consume much more of my time. Oh, we've picked up a few caps along the way. I don't know. The eraser, it's I think that's what they used to call them, yeah, magic erasers. It's melamine sponge. So these are just melamine sponges. I use them for clearing off most of the flux. And then it's good for when you're rubbing over like things with pins, because it can just it'll just get ragged up a bit but still touch the board, whereas if you're using like a cloth, the cloth snags on the pins. Yeah, these are almost identical to PPU and CPU's size chips, yeah. Same pitch and same footprint. I think that one I got a few shorts on it because I wasn't paying that much attention there. Just dragging it all over the place. So a quick look. Oh yeah, definitely wasn't paying attention doing this one. Got shorts everywhere. Probably just reflow him in a second, get these major shorts off. Yeah, I've done a terrible job of that. Let's just reflow him. I'll do this one let me just do this one under the scope. I was not paying attention at all there. We've got the hot air, I've got it at 490 at the minute, 490 and 90% airspeed. But obviously they're designed for this, so that's why you won't melt them. They're basically designed for transferring over. Plastic will melt though, if there's any plastic in the area, it'll melt plastic. Better. Yeah, hot plate you can use, I just think that's a lot slower in terms of doing this kind of work. You've got to take it off one thing and put it on another, and a hot plate will take a lot longer than hot airing. It's not that difficult to do once you've done a few, unless you just don't pay attention like I did on this one. And made an absolute mess of it. You don't normally need the soldering iron at all. This is literally, I think, the first time I've had to use a soldering iron to redo one of these chips. And it's also already got a slightly bent pin on the corner, so it's got to bend him back in. He's an absolute pain. Let me just desolder wick and do this manually on the corner. There we go. Yeah, let's just check that under the camera because I made a right pig's ear with that one. So we've probably got to clear some shorts off there. I think I put it on a good 4 or 5 pins out of alignment and then just dragged it around as I was talking. And let's just see what mess I made. I've cleaned up most of it, I think. It's fully zoomed. Let's go in digital. Yeah, we've got some shorts here I just need to reflow. Didn't spot them. Those look like shorts. That one there. I need some more flux on that one. I think they normally take about 15 minutes to do these boards, and then the last one I live streamed took about an hour. Everything possible went wrong, and then this one now that normally takes 2 or 3 minutes has taken about 5 minutes. There we go. I think that's slightly out of focus as well. Should be a bit sharper than that. There we go. Maybe that there. I'll look under the scope again after, but that looks like maybe a little short there. Yeah, it was. Right, so I think that's good now. What a mess. That's literally the worst one I think I've done. Right, let me just inspect this once more under the scope with eye. So I've got some depth perception. Yeah, that's on. All right, let's try to do a better job of the VDP, because that was terrible. Pay a little bit more attention this time. I've seen that recently. Nezis with region locks on. It's not a region lock. It's just basically I think it's the motherboards themselves just have some diodes on, basically to protect the circuit, but the diodes drop a bit of voltage, and I think they're also used as pull-ups. So that I haven't looked at it directly myself. I just glanced at it somewhere and then checked the schematic. You could always pull the schematic up and have a look, but something to do with basically one of the signals on the controllers, the data rail is left floating, not pulled up. So you need to modify the actual console, the NES. Just remove the diodes or add pull-up resistors, I believe, is the fix. But I don't think it was an intentional region issue in a sense. It was just a design choice that obviously was overlooked. Yeah, top left. Little solder bridge, good catch. Yeah, it'd probably reflow when we put the hot air on, but it's better sorting it now than when it goes on. And let's watch how easy it is when you actually pay attention. So let's get it on screen, so I'm also looking at what I'm doing if I'm checking the live out and not just talking away and not focusing on anything. You don't need to get the alignment that critical. I think it's just the other one was a bit extreme. I'd got it halfway down the board. It was like not even remotely aligned. So you can see this one's like a good full pin length out, but this should all pull in without too much issue. Normally it pulls in without touching it, so if we don't even touch this, you'll probably find in a minute. There you go, it just pulls into place. And then you can just nudge it up a little bit if we need. So a little bit of assistance there. Like so, and then push down, go around, and then I think the top of there's got a few shorts, and like I say, you don't normally get shorts, but if it does while it's nice and hot, just reflowing while it's super hot helps everything flow nicely. And then we should be, by the looks of that, good without any manual soldering iron work. Also remembering to put this bamboo rag, if you will, underneath it when you're working, so all the flux doesn't stain your silicon mat. Zoom in any closer. Yep, I think it all looks good. And then the crystals, I think I tried this on the last time I built these on live. the only time I've used the crystals, these are crystals I've had made, literally specific to us, so we've had to make 3,000 of these. The prototypes they sent me needed a slightly different load resistor, hence this remove these resistors of using OEM. When I installed this on the last stream, it didn't work, so I just removed it because I didn't want to faff with another added complexity at the time. We were having a nightmare as it was. I've since used them off stream, and it turns out the mass-produced crystals now use the exact same load as the Game Gear ones, which is good for me. It just basically means we remove these resistors regardless now, whichever crystal we use, the original or that. So the next revision, we will just literally remove these resistors completely. So there's no difference now between the OEM crystal and the one I've had made, which is ideal because then it's just something else that you can't go wrong with. So I've only installed about 2 or 3 of the mass-produced ones, so we'll soon find out. But the more I install, the more we'll find out if that's true, that they have the same load resistance. And hopefully they do. It's the crystal one, so I think that's everything on. We're doing multiple of these, so I'm going to be building about 4 of these, so you're going to stick around, you'll see a bunch more of these being made. They normally only take, like, say, about 15 minutes aboard to make. This one just went a little bit off course on the CPU because I wasn't paying any attention. But normally, if I'm paying attention, we should whiz through a bunch of these. The crystal, it's for keeping, obviously, effectively a constant beat, like a pulse on the system, so it knows when to operate. So every time there's a clock pulse from the crystal, then the system, like the CPU, progresses one step and executes code. So like when your CPU and it says it's, you've got a 1 gig CPU, it means there's 1 million pulses a second, or more than that, I can't remember. I think a gig is 1 million pulses a second. In fact, no, it isn't, because a meg is 1 million pulses, but you get the idea. 32 meg crystal will pulse 32 million times a second, I believe it is. So that's like the clock speed of the circuit then. We have the ribbons to go on. Yep, you'll literally see us. I've got another 3 here. I'm going to build up, so you'll see the whole process in a second. If this one works. Ah, nice. Glad you sorted that radio. Yeah, it's just, I used to take on most things, but like I say, I'm just flooded with work at the minute, so we really had to reduce what we were working on. Where's this power? Right, so that speaker. Let's see, do we get it? I don't think we've got a first-time boot on a live yet. Shocker, we don't this time. So first step is to just visually inspect everything. Let's make sure, well, I'll just do that under the scope because I haven't really looked under the scope at the chips. Let's just make sure I've not made any mistakes or bridges. That CPU was definitely dodgy when I did it originally, but now it looks fine. Actually, no, there isn't. There's still one tiny hairline short on that CPU still. See if we can see it. Yeah, so you can't see on the lens, that's why. But there is. Let me find out where it is and point at it for you. See if you can figure out. So, right there. Oh, you can there. See that little dot? That's why I didn't notice it just looking on the camera. So let me just clear him off. So, where's he gone? There. Well, that really is a small joint. Oh, there's actually a solder blob above it as well. Let me clear him off first. going to go down all the pins on that side on one. Sit. See if that's done the trick. Short on top left and bottom right. No, there was a short on the top left we've got. Bottom right, there's nothing on, maybe just on camera, unless you meant just down the left side that I've already reflowed. There may have been one. Let's give that a go. I think we're good on there now. There we go. So short of making an absolute balls up of the CPU, that's one working. So let's give that a go. That noise, when you hear that noise on here, by the way, that's just the USB cable. These are just purely debug ports. You don't use these for the final builds. So this USB is not filtered at all. So if I pause and you hear this, just the static or any noise, it's because the power from the USB is only for testing and debugging. You will get audio noise using a USB if the thing that, you know, the power that the USB is coming from has got noise on. Let's bring that in a bit. Upside down Sonic. Brightness wheel works. Yep. And then Japanese. Yep. So that's all good. That's one build. So we'll leave this. I don't tend to build them past this. What I do now is put them to one side. And then what I'll do after, because something I've never shown you yet, is putting the actual extension port on. So we still need to take this extension port on, off rather here, and put it on here. And if these are going to customers as fully built, which 2 of these are, I believe, out of 4, I'll also solder in these ribbons. But we'll do that last. We'll get the, the flat boards ready to go. Then we'll cycle back and chuck the connectors on in one go, kind of batch it up a bit. Oh yeah, I love the Sonic tune. We'll have to speed run it when I built one. Actually, I think I've got a fully built blue at the minute. And is it Sonic 1 or Sonic 2 I speedrun? I think it's Sonic 1. Side quest. I think this one needs, it's still on the bench because, zoom out a bit. Actually zoom out a bit more. I think this one needs, I know this one's fine, just hasn't been lens dropped. So let's see if I can do, it's in Sonic 2 I speedrun. Let me grab Sonic 2. I'm going to see if I can get, I normally get 19 seconds if I do a good lap. Oh yeah, the blue shells are absolutely flying out. It's like taking over all the sales. Everybody's just buying blue shells now. But I mean, it does look amazing though. It's really nice. And I think the fact that Sonic is blue as well, I think it's even just the background being slightly blue, it just goes so well. This has still got the screen protector on. That's that little bubble you can see there. We take that off just before we drop the lenses. So let's see what we can get. I haven't done this in a while. Ah, there goes the run. No, there's another miss. And another miss. 24. Quite a few mistakes there. If you get it perfect, though, you can get, like 19 is fairly achievable after a bit of practice. But I don't think we've ever hit 18. I think we say we should be able to get 18. Let's have one more go. That D-pad's a little bit stiff as well, I think. Might have to redo that. Also a bit hard with the studio light because I'm having to look from an angle and not directly overhead, because otherwise I'd be looking at it like this and you guys can't see. Let's see, 1, 2. Oh, I messed that up already. That might not be. Oh, yeah, that's terrible. That's just one more go. That was painful. Method for soldering flux wire braid. I don't tend to drop them on the solder anymore. You just hot air. But if you are going to do, then you just you wouldn't pre-tin the pads. You just align it first. So get it. Oh, I messed up there. Get it aligned as best you can. Oh, I've gone the wrong way. Okay, so 24 at the minute. For soldering, just put this back a minute. If you were going to manually do the soldering, so in fact, let's get the actual RePCB out. I'll get another one of these a minute. The glass, you can sell it, you can buy it separate. We just sell the branded glass separate because if we get sued by Sega, then they can only come at us for the sales of, other than damages, they could come at us for the sales of the glass, not the sales of the entire consoles and shells. But yeah, if you want to get the branded glass, you just order the glass itself separately, basically. It's just to try and protect us a little bit if we get sued again. So, let me find a chip a minute. I'll tell you what, save, I'll show you how you do it with soldering iron, but I'll do it on the little one. So we're not wasting it. I don't really want to do it on a big one, it's inefficient, but the same principle applies. So say you want to use solder and not hot air on this one. To get it off, you're just going to have to really struggle and run solder up and down, or put some thick wire either side so it heats up at the same time. But let's say this is the same for the A6. You'd basically leave them blank. This is why these aren't pre-tinned, in case you want to do it this way. And then what you'd do, or what I'd do, is get a bit of flux on the top corner. Get your soldering iron, lob some solder on, use your hand, put the chip in place, align it as best you can, so like that, lob on, so the chip's aligned, and now you'd flux the other corner. Try not to move it. Lob solder this side, and that's your chip in place. So then you check it's all aligned good enough, because you've got to really commit at this stage. So you don't want this to be misaligned, because this, you can't move it so much with a soldering iron like you can with hot air. So you see how this is slightly out. We could twist it a bit, so you've got to be really accurate on your position, you see. So like probably there, and then this side would maybe want to be up a little bit. And this is why you're only tacking a few pads, because you don't want to obviously have to warm up loads of solder to move it. So that's in position. And then what I'd do is either start top of here and down, or bottom of here and up. So obviously the chip doesn't move. So let's just start at the bottom. And you can't have too much solder. So all I'll do is blob plenty of solder on the iron, rub up and down. And as long as you've got a few pads tinned, you can then go anywhere you want. Plenty of solder, plenty of flux. And you see, because there's not as much heat, because yeah, you aren't using hot air, so you're just relying on your iron. until everything's warmed up and you get things flowing, you won't get very good transfer. So you just keep going until everything's nice and hot like that now. And then you can either just use your iron, touch on, lift off, and wipe off in like a pot like this with some metal fibre, and just keep doing that. And this will remove the excess solder. So you don't need anything special, you don't need debraid. You might just want a little bit more flux after a while to reflow. And then there's the bridge is gone. So you don't need to use desolder braid. And the problem with desolder braid is you can accidentally wick off far too much solder and you'll have a chip that looks like you've soldered it, but you've actually just got dry joints or floating pins where the pad at the bottom is soldered and the pad, you know, the actual leg of the chip is soldered, but they're not soldered together. So if I just use desolder braid, you can basically do that to rapidly remove the joints. But then if you do it too long, as I mentioned, these pins might not be flowed correctly. So just reapply flux, go up and down again, and you can just push down gently with your iron like that if you wanted to push down. But look how much longer that took to do that than hot airing the chip on. It's a lot more work. And then now the board's cool, so all the flux is cool. So now you've got to warm the board up to clean it. So the whole process of using your iron is just 3 times as long. If you've got the hot air and you do all the process in a nice order, then it's nice and quick. It's like way quicker than using an iron. Flux is needed to stop, well, to keep the solder flowing, otherwise it dries up and then just sticks to your iron because of all the contamination between effectively the contents of the solder. So it just goes dry. So it's to keep everything flowing nice and smooth. So we've got that one. Let's pick another random game gear. Let's pick this one. And let's see if he works. So now, if I pay attention to this, and let's try and get things into a good view here. Trying to make this so it still suits both horizontal and vertical screens. I think I need to move that vertical over again. I keep moving this vertical layout slightly. And there's about right. Right, so what we're going to do is pre-tin these pads. I'll get the fume extractor on. And then we pre-tin all of these pads. I think this soldering iron tip's giving up, it keeps beeping. I think that's all good. A little short there. Nice, good luck with them new builds. Let me know how it goes. What shells are you using? What colour shells are you picking? Or is it going to be all sapphire now? That seems to be what everybody's buying. For this pre-tinning, I'm not really pressing down. I'm just dragging along. So you're just literally touching and dragging. You're not really applying any pressure as such. So we have that on. Next we will hot air these chips off. Yeah, the cyan, is it the cyan magenta by chance? That's probably the second most popular UV printed shell behind Master System. I'm tempted to, obviously we UV print the Master System, but we sell that many now. I'm half tempted to have them mass produced as a proper print, but the problem is, again, trademarking. It's got Sega and Master System on, so it's going to be almost impossible to ship in, to be honest. But the cyan magenta splash I could actually mass produce, and then it'd be a much higher quality finish as well. For hot airing these off as well is roughly about a minute, so the iron's about the height of this connector, and you can see I don't give a shit about burning this connector because we're not using it. After about a minute hovering above, we go closer for the last 10 to 20 seconds, and then it lifts off. So this has got about 5 seconds left and we should be good. That's some moisture inside the circuit board popping. There we go, just released. Now let's pay attention to the CPU position this time, because I didn't really focus on this at all last time, so that's about a good enough position. Get some flux on, and then repeat it again. Business Mastermind is definitely rusty. He's the one that keeps everybody happy and keeps everybody working so he can get fed. If work dries up, then he can't have chicken and treats. And there you go, that CPU's just pulled into position. Give it another 5 seconds, say, when it's pulled into position, and sometimes you still have to nudge it slightly, which I think now that's perfect. Push down, flow around for another 5 seconds, and then we can, just while we're pushing down, apply a little bit more flux to help all them joints flow good. And I think we've maybe got one short up here, so I'm not even sure, but I'm just going to touch it with the iron while everything's nice and warm, and then if there is a short, it normally reflows off. I think that's good. Hold it down for 10 seconds, and then timing this just right, we can then clean the flux off before it starts getting tacky. So another few seconds, and go. Yeah, just the right time. It was starting to harden. If you come in with the IPA too soon, then you're going to, basically you'll have molten solder still, and you'll make the joints all rough and potentially drag the solder somewhere. And if you come in too late, the flux has dried, and then you have to warm it back up to clean it well. So it's a fine balance between getting used to it and the time at which you come in to clean. But that's how you're meant to do the CPU when you're paying attention. That looks, I think, nice and clean. Yeah, look how much cleaner that is when you're paying attention. You can just see the difference in the quality of the joints compared to the last one. Just nice. It almost looks like a nice factory finish. Got a little bit of flux there, so we let it cool down a little bit too much. But as we're doing this one and warming this up, that'll end up getting cleaned off. So same again for the VDP. So a bit of flux. The flux isn't needed so much on removing this. It just, if it already looks a bit dirty, then while we're taking it off, it's getting a natural bit of reflow and cleaning the pins. Short bottom centinode, you see even on the stock one there, that's 2 ground pads, so it's actually meant to be joined. That's the only place on both ASICs though where it technically is 2 pins next to each other that are joined together. Sponge, this is melamine, or melamine sponges. I think people call them magic erasers as well, somebody mentioned. And if you do it quick like this as well, where I've taken it straight off, kept the heat on and transferred, then obviously the drop onto the board can be about 30 seconds quicker. So there's the pull. It's aligned perfect, so we'll just push down. Another 10 seconds. There we go. And if you want to really get them smooth solder joints, a bit more flux after you've finished, and this will really just react with the solder, make a lovely, perfect, clean bubble, hopefully. It's hard to tell if we have any shorts under here because of the flux. If anywhere, maybe a bit down here, but I don't think there's any shorts, so I'm not going to touch anything. Flux is Styri. This is ASM. It's a bit more tacky than the V3 I've been using, but it's still really good flux. So next up, oh, I've dropped a load of flux all over the headphone connector somehow up there. I'm basically working my way through all of the flux from I always want to say Styri, but it's just Styri, isn't it? If that's how you pronounce it. I'm working my way through all of the fluxes they offer to see which is best, and using the whole tube as I go. But so far, the V3 HF has been the best one. None of them have been bad, not a single one, but V3 is the one to recommend at the minute. There we go. I think that looks nice and clean. Do we have... Yeah, they're not shorts, they're just a bit of dirt. So that's the bit of grime that was on the VDP pins originally that just hasn't quite flown off. But yeah, soldering looks good. So I'll do one quick visual inspection under the scope, just to make sure, because I've done all this work using the cameras, I've not used my eyes to really check these. But from the camera's point of view, they looked okay. Yeah, so that was good. So we didn't need to use the iron at all there. That's what should happen. You normally find that if things go to plan, you don't need the soldering iron for this job, other than to tin the pads. This board, it is a Game Gear RePCB, it's called. So it's basically a remade Game Gear. So there's the original Game Gear motherboard. This is a completely remade motherboard that I've designed and made so that we can put the A6 and Z80 chips on. So it's still real Game Gear hardware, but then a brand new board, so that if you've got rotten boards or ones you just can't fix, you can make use of the Game Gears. And I've got literally tubs, I think we're down to our last tub, but tubs of Game Gears that were too damaged to sell to customers at the time. This is before I even made this board, I just kept them. And now I've got these boards, I literally have used almost every single Game Gear, so none have gone to waste. So it really helps for when the motherboard's too damaged, saves it going to, the skip. It's actually having a new life and going on a brand new board. What next? Screen. And I think that first one worked first time, didn't it? So we just had a short on the CPU that I messed up. Let's see if this one does. Sometimes you can do literally 5 in a row, no problem, and other times you can just have problem after problem. So what do we reckon with this one? Going to work or not going to work? I reckon we're going to have a bad VDP, because it's always the VDP. And then if you do buy these sponges and use them, you'll see after I've cleaned a while, I just then snip off with scissors a bit further down. Otherwise, the flux in here just keeps spreading. And you can just keep cutting this down and be using the sponge about 6 or 7 times. Did I put Sonic away? Yeah, oh no, it's there. Alright, and let's see if we get boot. Oh, wait, no, we haven't put a crystal on. Let's actually put a crystal on. So we just need to remove them resistors. And I've just mentioned, not that you'll actually get your hands on these crystals anyway, because it's ones we've had made and they're not on the board yet, but originally we were going to have to remove these resistors when using the original crystal, or keep them on otherwise. So at the minute everybody has to remove these resistors as part of the build because you don't have my custom crystal. But the prototype crystals that I had samples made. They needed a slight different resistor to work than the original, whereas these mass-produced ones, now I've got my hands on them, they actually work just like the originals. So they have the exact same resistor load as the Game Gear crystal, which is ideal, because now the next batch of these will just have the crystal built in, and you won't have to transfer a crystal over. Spent all that time lining that up and it came straight off. I'll just give that a minute to cool down. It should be good. Let's see if this works. What do you reckon, going 2 for 2? No. That's a crystal issue. Maybe the crystal's just a bit too warm at the minute. So that's why we have the sound on as well, because if the crystal's running but too slow, then you'll hear the audio at the wrong speed, but you won't see anything on screen. Let's try again. Oh, and there you go, VDP. I called it. That's definitely VDP. Only because I've seen so many of these now. I know for a fact that's a bad VDP. It's not bad soldering, that's just a bad VDP. So I'll show you on the computer. Let me just pull up the wiki. So you'll see what I mean, because it's such a distinctive visual glitch, it's not soldering. So if we go to retro6.wiki, go to Game Gear, and the stupid new wiki closes every time you click the header. RePCB, scroll all the way down, and there you go, bad VDP examples, glitchy. This is a very common one, this kind of weird half-moon penguin kind of thing. But obviously, that kind of visual is exactly what we see on here. So that's going to be just a new VDP. And unfortunately, when that's the case, you've effectively got a situation now where this Game Gear is ultimately of no use in a way, because you've got a CPU and not a VDP. So you end up with a mismatch, and I've got tons of CPUs for sale. Well, we don't even sell them yet, but I will be, because you can see here's another one where we've robbed the VDP and we still got the CPU on. But that's what it is. You can't save them all. And at least we know the more you build, the more the problems aren't problems as such. You can rapidly identify the issue. And I know without even looking further, that's just going to be a VDP. So we just have to swap one over. It's not that difficult. VDP is visual display processor. It's basically the thing that generates the image on screen. So it works with this VDP and on the other side, the video RAM there. So it stores data, stores like the screen buffer in the video RAM behind, and this thing is what generates the data and puts it. This generates the data, sends it to the CPU, and the CPU outputs it onto the screen. But the fact that the video image is corrupt, this is the VDP. Yeah, it's very similar to a GPU in a sense, like in the modern sense, I guess. And then what I'll do is also, I'll note down this serial number on the bad one and add that to the wiki again. I keep a note of all the serial numbers, because the serial numbers tell you, you can't see it on this one, I'll show you in a minute. They tell you what factory they were made in, what year they were made, stuff like that. So my goal is to see, with all these VDP failures, is there a commonality? Like, is there a specific year or factory that's more than likely going to be a problem? And then I guess when you're putting chips on, if you've got that exact model or version, you can kind of be a little bit presumptuous if you have issues, that's what you need to look at in there. 9121K7. So 912, I believe, is the manufacturing year, 91 probably. Or is it 96 and 97, the Game Gear? But either way, I believe these digits represent the year and these last three represent the factory that made them. And I'm sure 912, if I pull up the wiki, is one of those common ones. So all the failed ones, no, actually it isn't. I've never had a 912, it's 921 I have as the failure. So this is the first time we've seen a 912 fail. We saw a 913 fail 2 days ago. And there may not be a commonality between them, it's just something worth keeping track of. And then we might find a pattern in future. You can't get them remade, no. I mean, you can and you can't. I could probably make an FPGA, or, yeah, it'd probably have to be an FPGA. I could probably write some code for an FPGA that mimics the behaviour, but then, in my eyes, then you're basically emulating, which there's no problem with emulating, but if you're going to emulate, then that kind of defeats the purpose of what I'm trying to do with these RePCBs. It's always meant to be true original hardware. That's what we're going for with the prestige things we sell. It's all about the fact that they are real. The original old consoles just done up. And obviously some people will argue that at what point does it stop becoming a Game Gear? And what, same with the Game Boys. Well, if you've got new speakers, new battery, new shell, new rubbers, in my eyes, the only thing that makes the Game Gear unique is these two chips, the ASICs. That is running the hardware. So long as those are on, in my eyes, this is genuine hardware. You're just experiencing the audio and visual with upgrades, but it's everyone's preference. It's literally completely preferential, whether you want these on and think they're original or not, or whether you want an original screen and experience the true originality. There's no right or wrong. It's literally what brings back the memories for you. What makes you feel like you're playing on the same console that you had as a kid, but that you can actually hear and see. And then, you grab an original Game Gear and you can barely see the screen. So you're focusing more on trying to see what's on screen than enjoying the memories. Overheating chips, you can. It's a lot more difficult than you think it is. You can have taken VDPs on and off to prove that the other ones are faulty multiple times. You can have them bubbling, you can have the boards popping, like when you heard that pop earlier on, I think, the CPU. That was just moisture in between the board popping, but you really got to overdo the heat on these to damage most chips. So I don't think I've ever consciously damaged one with heat before. That's most people's fear. Oh, don't get the chip too hot. The reflow profiles are like 270 degrees. Well, we've taken these up to 500 degrees in terms of hot air. Obviously, it never gets to 500 degrees because it cools down, but there's a lot more tolerance than you think. I guess if somebody, what you can do, but this is similar to what, Analog don't do it, they reverse engineer in a clean room environment in a sense, where they don't look at the original hardware, but you can clone these chips. You can just delid them and basically just heat this up. So I could probably do it on this chip, the failed one, to show you, but just heat it up a ton, crack it open, and then you'll see the silicon die inside, which has got all the transistors and layout. You can then have that cloned and spin up a fabrication of it, but you probably need to make like 100,000 is normally roughly the run-up cost of modern factories if they wanted to make this. First, they'd charge you probably 20 to 30 grand if you know them, and 100 grand if you didn't know them, to clone the chip, and then they'd run a production run of like 100,000 chips, and they'd probably cost you like £2 to make. So if we were going to sell 100,000 Game Gears, I could literally clone this chip perfectly, but obviously that's never going to happen. We're not that popular, and I don't think you're ever going to sell that many Game Gears. So let's see if this now works. New VDP. Hopefully we're not bad in our luck. Why is all this stuff over this? It must be dropping flux without noticing. I have had this where I've swapped VDPs multiple times and ended up with multiple failures, so there's no guarantee that the second VDP is going to be good. Perfect example there, even worse. So let's just check. This is a Game Gear, so this is the original Game Gears. This is a new circuit board I've made to restore Game Gears, so you can take the chips off and get them running again. So I think we must be looking at another bad VDP because that's soldered fine. And this is what I mean about them. They genuinely are. If I didn't have so many and I wasn't that confident in the fact, I'd say there's no way you've got two faulty ones, but the likelihood is this is yet another faulty VDP. That's not a short, that's just a bit of dirt. But yeah, that's all soldered well. You can see it nice and clear. So let's do, and this is where you'll find out it's, what you can do at this point is, if say we're at the point where we're about to swap another one, what I could do is use this one and take the known VDP off and put it on here, and you know it's going to work. And then you've got the confidence that these two are faulty, and you can put the faulty one back on here and see that stop working. Or we can just grab another board and swap another VDP. And because I just know this, I know these are both going to be faulty, I'm just going to swap one more. If we see this third one being faulty, then obviously we'll suspect something might be amiss here, and we'll go back to putting the known working VDP from the fully working console onto this board. But I'm sure you can have, see, the other thing is you can have, say, that VDP was faulty, now it's working, it's something else doesn't, but the fact the game fully loaded and we had visual, that's 99.9% not the case. So it's going to be the VDP, but one thing I didn't double check in the rush is just quickly clean the game. No, so it's definitely dead on that. Or saying that, one thing, there you go, I've just thought, one thing it can be This crystal is, you know, I mentioned these custom crystals. It seems like they do have a slight variance in the load. So this wants to be loaded down slightly. So what I'm going to do, that VDP was definitely bad because obviously we saw it when it booted bad. But this issue is now actually the crystal. So I'm just going to take this crystal off, and I need to carry on doing more tests before we obviously put these on the boards, because this is another one now that's got a slightly different spec than the last one. So the last one worked, and now this one doesn't. So they do still need slightly different load, I believe. So to just eliminate that from the equation, let's just put the original crystal back on. Or the original crystal on in this case, not back on. That's it. And now this will almost definitely boot, but let's see if this new VDP is good. Oh, interesting. Yeah, so bad VDP again. So the bad VDP could be pulling down that other crystal, but this crystal can handle it. So yeah, we've got, I'm going to say we've got 2 bad VDPs. So let's carry on with what we were going to do. Let's put that 3rd VDP on first. But yeah, this is what's happened to me before. I nearly lost the will to live at one point, because the first thing I did was built up I built up a load of RePCBs, like I probably built 10 in a row without issue. And then the next time I come to do them, I literally had 4 or 5 in a row where everything was just faulty. Multiple VDPs were faulty, the Z80s were faulty. I just literally couldn't get a single board working, and I thought there was maybe a problem with production. And when I finally got through it and got things working, and then put the chips back on, it really was just, there was tons of faulty chips. And you have to bear in mind, these are all only in my tub because we couldn't get them working. So these are all Game Gears that we couldn't get working. So that also adds to the chances that these chips we're using at the minute are ones that are potentially the problem, and not necessarily the circuit board's the problem. So we're using the worst batch of Game Gears we have to try and, you know, get working consoles at the minute. Let's swipe a load of components off while we lift it off the board. That's the way we do it. I've got a graveyard of Game Gears now on the desk. Right, let's take this one off. And this one is a 913. Let me just look at the wiki on 913, see how many of them we've had faulty. Only the one yesterday I had faulty, and that made, funnily enough, and that one, the 913, yeah, we had boots but corrupt graphics. So very similar. Going to be setting a mini fire in a minute with this rag underneath. Third time's the charm. Look at that lovely straight VDP. There we go. You never noticed it wasn't level. I think I thought I saw a short, there wasn't one, and I put one on. That was a good job. Wow. Should have just not touched it. Okay, we'll get that off in a minute. Get a bit of extra flux on first. Make sure all them pins reflow nice. And that's good. And let's inspect it again, third time. Oh yeah, that was bad. That was because it was quite out of alignment, obviously. Just being lazy, but shouldn't be a problem to remove. Wow, I think it's short on nearly every pin on the whole chip. That one's okay. Yeah. Yeah. That one's really hard to get on camera. Let's turn him sideways. Maybe lift the focus up a bit. Wow, reflections. I literally can't get that to not reflect the edge of the board. Yeah, there we go. All looks good. Yeah, a few people have asked for the clean screen to be integrated, but the clean screen just plugs in with no soldering. And obviously this is an expensive board, so is this. And if you break one thing, you broke the whole lot. So it's one of them where keeping it at least modular to this level, I think, makes a bit more sense than integrating it fully. There's no saying I won't do that in the future, though, but it also gives people the option that if they don't want to use the clean screen and they want to use some other inferior product, they can. And here we go. There's no way we've got 3 bad BDPs. There you go. So confidence in what you're doing and the fact you know these. So Sonic again. And then just all we can use is the start, or right and left on the clean screen here to test, because they are used on the menu. So that's how I quickly test it. You can pause, you can jump, and you can move right, or move left rather. And then normally that's pretty much, good enough for, there's rarely a problem after that. So I'll move it to one side and presume it's working. And then if there's any problems, we find out when we come to build the console up fully. But generally, you won't get an issue if you get that far in the build. That's that one done. So now we have 2 built, but we have 4 Game Gears we've had to use. So instead of building another one, like another full one, because I'm a bit pressed for time before I need to go tonight, what we'll do is get the connectors off here and the chips we want to use, and probably show you that, because that's one thing I'm not very good at. So you might as well see me struggle on something a minute and see if you can give me some ideas. Yeah, I could do a green one. The kind of Retro 6 theme is all white. It's what we've become known for. We used to have, funnily enough, I think this actually. This is a SYF board, so this is a guy called Matt that made, I think, the first real Game Gear remade board. You can see we used to use them, but we just had issues with the connectors not being great, and the fact that because we don't make them, these cost a lot more. So by the time we come to offer them to customers, they were too much. But what I was going to say, I just saw this purple. We used to have purple boards, and then because other people have used purple, we moved to white, and then people just loved the white, basically. But I could do a limited run of green, just make, one of the batches in green, because we still need to offer the white. People definitely like the white colour. I don't know whether I've gotten old. I think we've binned them all, but we had old. Probably pull it up on the internet, like the original clean screen V2s, I think they were. Sure, I'll find an image. Oh yeah, I did a video. So there's, funnily enough, get this one. So you can see how the SYF board's purple and our board's white. Well, check out what it used to be. SYF's board used to be white and now it used to be purple. So it's literally the exact opposite. We've flipped around. So now theirs are purple and ours are white. Alright, so let's just get, this is, we need to take 2 CPUs, 2 Z80s off because we want to keep them, and then we can scrap these boards when we're done. So let's just hot air these off, nothing special. I'm not going to use flux because I'm going to take these straight off for now and put them in a tub. I don't want them to be messy. So if we look at these, I'm just going to hot air them off. And then I'll add those 2 VDPs to the wiki that they were failed and bad. And both of them, if I remember rightly, both of them booted, but both of them were corrupt because I've also made notes that some of them actually prevent the console booting, which I didn't think originally, but then it turns out it does. Normally, if the console doesn't boot, it's one of the other 2 chips, but I have known certain VDPs to stop boot completely. So I do keep notes of, you know, how they fail. And it just helps to diagnose things like how quick was that for us to go. Oh, it's a bad VDP, swap it, or it's another bad VDP, swap it. Whereas when I was first doing this, you could be swapping CPUs, Z80s, wondering whether your soldering's good. There's a lot of questions and doubt at the start. Whereas once you've done enough and you're kind of confident you've seen it enough that that's what it's going to be, then even when a chip's bad, it doesn't take that long to build up. This is a Stream Deck. I'm switching with just, I'm using the virtual one, so it's easier. There's no point having a button on my desk when I can just grab the mouse, but yeah, I've got all the Stream Decks. I've even got AI built in, so I can actually talk to my camera and tell it to track my face and swap scenes, but I don't want to sound like an idiot asking it to change scenes. That's that one done, so we'll get the connector off last. This one we'll rob the Z80 from as well. Yeah, when I swap scenes, there's a lot more going on than just clicking a scene as well, because we've got like the overlays, so like the PC overlays. I can overlay it like there, and the way it has to switch as it toggles between scenes, so if I click the other scene, that can go over. And, you know, re-showing and hiding all these sources is obviously a few actions, so it is basically a Stream Deck, but when I realised they got a virtual one, and considering I have to look at the screen and click things anyway while I'm working, I just put it to the top left of my screen and just use the virtual one. Mega Drive, yeah, it's fairly easy to do because you probably just need to write a bit of Arduino or Raspberry Pi code to. It's got nothing on, right? It's this one. You'd have to convert the that's hot. The Mega Drive interface into just basic up and down arcade style buttons, just literally syncing to ground. So you could either leave the controller stock and write a bit of code that converts Mega Drive interface into just physical button presses, or you could just modify the Mega Drive controller to just have each button physically just short to ground. So there's a few ways of doing it. Now that's the chips off that we want. So now the only thing we want here is these connectors. This is what I'm no good at. So this is the bit where I've said I'll leave these up to Zach to take off just because I don't like them, so I haven't practiced much. So these extension ports at the side, this is what I'm no good at taking off. So let's zoom out a bit. So there's a few ways we can do it. Obviously, you can desolder all of the connectors and it drops through. But the desolder wick for me, I'm not a fan of. What I tend to do is hot air. Zoom out a little bit more. I tend to hot air things and use a desolder pump. So I'll, heat it up and then desolder pump. The problem with that is the connector melts inside if you do that. So really, you're left with desolder wick. Desolder wick, I don't think always does a good job. It sometimes does, sometimes doesn't. Well, that reflection is not good. So let's just give this a go. I've got another idea as well, which is to desolder wick, because the problem why this doesn't come out easy is these two metal arms are often bent, so that even if there was no solder on, it wouldn't just drop out because the metal arms are like hooked like this over the circuit board. So the real problem is these connectors here. You want to make sure they're clean. So I'm thinking desolder the edges and then just flood the middle with solder to warm up all the pads in one go. Yeah, the problem with wrapping the copper around as such is it's not going to drop out because these metal tabs are bent. This is the reason I don't like this and why it's so annoying for me, because like even this doesn't want to desolder it good. So you can see that. No, not good. It's probably just, like I say, a lack of experience as well. I haven't done them enough to really see this, but look at that. It's no good. It's still connected and still dirty and grimy. It's even hard to see on camera, but see the bend, how it's bent over. So even if you fully desolder wick it, it tends to hook on. So the logical thing is literally to just try and warm everything up in one with a bit of solder. But I've tried it, and that's what I try most times, and I think it doesn't work for me personally. So let's just try and do what I'm thinking here. You can try it multiple ways. We've got to get 4 of these off. So I'm thinking desolder wick this. Maybe put some flux on while we're doing it. Yep, there you go, just as I was doing it. Flux on the braid will help a bit. But you'll see, you'll push that side and then it's still stuck to the other side of the board. So now you push this side and you can kind of push it off the connector. And then that's like, as good as you're getting. And I don't think it's that good. It's still stuck. And I like to do things efficiently and fast. And this to me just already feels like it takes too long. So this is why I get annoyed with these ports. The solder is already got flux in. So has the braid that's got flux in. I'm using a semi-cheap one here, mechanic. I normally use Gootwick, which helps a bit, but I've got some of the old stuff that I'm trying to clear out. So yeah, this is where I get to, whereas I want a solution. I want to hot air, basically. That's what it's killing me to not do. So I'm still going to go back to my old idea and ignore the iron and ignore the fact that other people can probably do it with an iron. I want to use my hot air. So I'm going to try and get this off without melting it. So I think in order to do that, because I just think it's going to be the most efficient and simple and not wasting desolder braid and all that good stuff, I'm going to flood the pins with fresh leaded solder so they melt a bit easier. Like that. And I'm just going to get the hot air. And what I'm going to do is go max temperature. So basically the idea is, and hopefully the air can't flow into the connector quick enough to melt it. So let's see if I can do this. And I'm trying to think, we need some weight. What can we do here? Put a box on to keep that down, because I want to be able to pull this connector, you see. Let's kind of grab in there and pull down. So I need something heavier. What's heavy? Need literally a big lead weight. I really shouldn't use my thermal camera. That's a bit too expensive of a lead weight. Maybe 2 boxes. No. yeah, that's pretty much the technique I've tried that should work, and that, like I say, Zach does it. He just floods it with solder and pulls it out. It just doesn't work for me. I'm just no good at that. I like hot air. I've got so used to using hot air. So I'm going to get this to, let's just try this. 500 degrees, 120 speed, crazy hot. The main thing is pulling this off without this board flexing around, but let's just hold it and see. I'm just going to go ruthless right onto the board as well. Yeah, melting that board, which is no problem because we're not going to use the circuit board, but you can see how it's still stuck because there's plastic under this connector as well. So that's off, but it doesn't. It might be okay. It doesn't sound the best because you're like creaking the circuit board to get it off, but it's basically them tabs. Well, we had a ton of messages flooding then. That was a lag. I guess I should read them. Jeez. Don't know what happened there. Has the stream been lagging, or is it just has chat just lagged then? Low melt solder. Yeah, I use low melt solder. I've got it somewhere, put it away. I've got bars of it, but I haven't used it for a while. That probably would work good. Retro Pug is crying, funnily enough, outside for probably his dinner. I think Manda's just fed him, so I need to go see him soon. And then I think all those messages disappeared after as well. We've had a flood of messages show up and then they've all disappeared. So let's just see now if that worked. Oh, there we go. So let's just see if I've damaged this port at all or whether it's usable. That's the key here. So there we go. Let's zoom in on this and see if this is a viable thing we've just done. Oh yeah, there's nothing worse than when you can't do something. It is annoying. To be honest, that's looking quite clean. The concern would be melting this plastic, you see, because this plastic sits on the PCB. So as you're getting the PCB hot, this can melt, but that just looks like dirt. I think that's come off clean, you know. We've obviously got to clean this port up because there's a bit of electrolyte in there. But did that work? I think it has. But yeah, see these tabs? This is what I mean with the tabs. They bend over and they kind of hook into the circuit board, so it'll never just drop off with heat. You've got to forcefully pull it out. But no, I'm actually pleased with that. Let's try that again, see if that was just a fluke. Because then that's a nice, super quick technique. That's what I'm after. I'm after something that's, you know, I can take off as quick as the A6, because at the minute, me putting this port on takes as long as literally transferring all the chips over. So I'm not even going to use, in fact, no, I should. Let's not be daft. Let's at least put leaded solder on. That's something we should do, because that melts a lot lower temp than the lead-free solder that's lightly on here. So fresh solder, and bear in mind we also desolder whipped the big pins on the last attempt, so that might have helped a lot. Whereas this time, flood it with solder, crazy hot air, and grip so I can twist. And the idea is I can kind of bend down, so apply upward force to bend it down and out. And then just as close as I can get to the board, you want to get this off as fast as possible so that we don't melt the connector. HDMI is coming. It's part of the V4 release that I haven't released. The thing I did that I shouldn't have done, I announced I've got a V4 coming and everybody stopped buying the V3. So we've got hundreds of V3 in stock first before that comes out. And then once it does, the idea will be it'll come with RGB, and I'll make another board that converts that RGB to HDMI. See, so this one's come out kind of similar. That didn't feel as good though. I've got a feeling that's not as good. It's not too bad. I think we might be on to a winner. So other than we've got a bit of a solder bridge, which we can just put some flux on and warm up, I think that's worked again. So all that complaining I've been doing and leaving these because couldn't do them, I think just blasting the thing with hot air as hot as possible and as fast as possible. That's come off clean, and you can see the inside, the main thing we don't want to melt. There's no melt in there, that's just IPA or flux there, that shine. So yeah, I think that's actually worked. Yeah, okay, so there's the solution. Well, at least my solution. So quite happy with that. And then once I've got the A6, Z80 and connector off, this is as good for the bin. And obviously I don't really want to keep the crystals. I need to figure out why my crystals don't work. Which I know it's them resistors, but what I might have to do is, if we do find out that these crystals, the custom ones I've had made, are slightly different on load, because it's the Game Gear ASIC that's got to drive it, I might have to just put a little potentiometer on that you turn with a screwdriver to tweak the load of the crystal and you struggle to get it booting. But hopefully I'll just find, the perfect resistor value that works across many of them. So the next ones I build, we will use that crystal and continue to use the crystal, so we can test enough of them that we're confident that we've got the settings right for it. So we don't need a desolder wick now. We don't need flux for that. We can put these away for now. And, oh, didn't put that on the flux. We actually need them, not the cutters. So we have, we forgot to take a CPU off here. We'll take the CPU off. And then let's do those 2 connectors again, see if we can do 4 connectors in a row without a problem. And then if so, I'm pretty confident I can get them off then without complaining. Hey, glad it's been useful for you. I do, to be honest, I think like 3 of the 5 or 6 lives I've done have been RePCBs, because that's all we seem to be doing at the minute in terms of every day. We're selling several of them, so we're having to constantly build them up. But everyone seems to enjoy these, to be honest. Even though it's repetitive in one way, it's, we're doing the same thing. There's always new people on, and we're always interested in, what it is and seeing it being done. So if you guys are interested in it, I'll still show it off. Yeah, that's not a bad idea with the tabs. We could always, we could try it on, that one's got nothing on now. We could try it on this one. I don't know why I've still got this on my desk. We're not using flux now. So, what you're saying is we should get these. In fact, I'll probably use a bit of flux, it might help. Get a bit of solder on this connector, say, like so, and then I could use these pliers and just pinch it together, get it nice and hot, and then pinch and straighten. Yeah, that's straightened, I think. And then if that's true and that works and it's right, then what should happen is the connector should practically fall out, shouldn't it, when we warm it up, if this is straight. Let's try the cutters. Yeah, you kind of need something. I need proper pliers. I'm using 2 tools that aren't pliers to do this job, but I think that first one worked well. I think it. Oh shit! Just cut through the connector there a little bit. That's cheating. I don't think he cut it all off. I'll just get proper tools after, but I think I've straightened them out. Yeah, them tabs are straight. So let's see if that now just drops off or not. Let's just zoom out a bit. So same idea. What I'm going to do is, actually, let's try not grabbing them. Let's just try heating up and seeing if it falls out. Oh, wait. I didn't put solder on. Let's make it a fair test. There we go. We've got leaded solder on. Now let's heat up and see if this just falls out, which is technically what it should do. No, I don't think it's going to, and I think it's probably warm enough to pull out. So, yeah, I think it's just pulling out. So that was practically molten, then it's just solidified. So the tabs are still catching. I might not have just melted them, bend them right. But it's just, the tabs are the only thing catching on that. If we could get them tabs right, we'd be in for a winner. Let's just inspect that one, make sure he's not damaged. And yeah, that's why I didn't do a good job of bending them straight whatsoever. Let's zoom in or zoom up on that. Yeah, you can see this, they're about as bent. They are slightly straight, but I think just as long as you're damaging that board in a sense, the old board that you're not going to use, I think just get used to bending them out. It's not, once you get a technique that works and you know you're not doing damage over and over, you can kind of trust the process, and it's just about having that technique that you get used to. So that's not bad now. I'm fairly confident in removing them ports. Let's just do one more, and then I'm going to call it a day. So this one is, in fact, let's try this one then without the solder. Let's try cut that step out so it's less work again, and less requirements. You can just literally warm up and pull out then if so. And I don't think the old solder is going to resist 500 degrees of heat anyway. I think it'll still work. Yeah, trust me, I've tried cutting the board up as well and hacking it up thinking it'd work. But again, a little bit messy, a little bit time consuming. It's just all about me trying to find the quickest way of doing this. So if I've got build 10 in a row, which is some days, that's what I have to do. I just want the quickest technique. The least amount of tools or requirement. Yeah, so the solder definitely helps this melt quicker. I think the solder's obviously not needed because we've got that off, but that did seem to take a little bit longer. So weighing up the time between doing the bit of soldering versus just hot air and pull out. But yeah, we're not melting them, that's the important thing. Look at that, it's perfect inside. So that's another skill learned, and I'm sure I'll improve that the more I do it, and then maybe you'll see me doing it a lot cleaner than that in future. Yeah, I'll definitely practice some of those techniques, like getting it out. The most awkward thing there is literally holding it and kind of bending and twisting. If I could find a nice technique where, a certain twist always works, that's what I'll try and perfect over, the next ones I do, because I'll be doing these all the time. So that is, I didn't get 4 built. I need 4, but I didn't quite get 4 built. But we got 2 built. One was crap soldering, the other was 2 bad VDPs, so if everything went to plan, I probably would have got the 4 done in time. And then we had the issue with the crystal as well, which I need to look at and focus on so that these little crystals I've made work every time. And then there's them 4 I can put on. So, yeah, that's it for that one, guys. Thanks for jumping on and joining in, and I'm sure I'll be probably back on again tomorrow. Don't think I'll be on tonight. Got a bit of a headache, so I'll probably call it a day for now. But yeah, thanks for all joining in again. Thanks for all the kind words, guys. See you shortly.